Okay, let's do another problem here from chapter 5. We're dealing with things going in a circle and the forces, acceleration, and velocities of those things. A ball is traveling at a constant speed of 5 meters per second in a circle with a radius of 0.8 meters. What is the centripetal acceleration of the ball? Okay, I'm going to draw out a picture here. Going in a circle. We know the radius is 0.8. We know the velocity, the tangential velocity. So if we looked at it, if it wasn't going in a curve, if it was just going straight like this, it's 5 meters per second. And we're looking for acceleration. So centripetal acceleration. Don't know what that is. Not just the acceleration, the centripetal acceleration. But we do know what the velocity is. That's 5 meters per second. And we know what the radius is. That's 0.8. So if you look at your equations from after reading chapter 5, you know that the centripetal acceleration is the velocity squared divided by the radius. Okay, so really all you gotta do is plug and chug, but I'm gonna look at the units. We have meters per second over meters. This is gonna be squared because we have a square here. So what you get is meter squared over second squared over meter. Well, meter squared divided by meter goes like that, and the units would be meter per second squared, and that is the units for acceleration, so we're good. We want meters per second squared. So now let's just plug in numbers. You have 5 squared divided by 0.8. That's the centripetal acceleration, and the unit will be meters per second squared. You can plug that into your calculator to solve for it. I'm not going to do that for you. Alright, let's try another problem. A car rounds a curve with a radius of 25 meters at a speed of 20 meters per second. Good thing it's in 20 meters per second, not miles per hour. What is the centripetal acceleration of the car? Oh, so we're just looking for this again. We don't know what that is. No, the car's not going in a circle, it's just going in a curve. But every curve is really just a little portion of a circle. So your car's, driving here, going on the road, going around this curve. Well, you can imagine that. Okay, so if that's the road, imagine that the road, if it kept going instead of like, the road might go on like this, and it might have came in like this or something. I don't know. We're just looking at this curve here. It's really just a small portion of a big circle. Okay, so we know that the radius of the curve, so if we looked at the big circle of this curve, that the radius is 25 meters. We know the car's acceleration. Look at the speedometer, and it's going 20 meters. 20 meters per second. Alright, so velocity is 20 meters per second. The radius is 25 meters. The equation that we'll use, just like the one before, is acceleration due to centripetal acceleration is the velocity squared divided by r, the radius. I just proved to you the problem before that our units should be meter over second squared. If you don't get that, rewind, look at it again. So you're going to take 20 squared divided by 25. So do this first, take 20 times 20, hit equal in your calculator, then divide by 25. And that is your answer. I'll let you figure that out with your calculator. And don't forget your unit, meter per second squared. Let's do another problem. Okay, a 0.25 kilogram ball moving in a circle at the end of a string has a centripetal acceleration of 4 meters per second squared. What is the magnitude of the centripetal force exerted by the string on the ball? Okay, we have a ball here. I don't know if you can, let's make it a green ball. We have a green ball here. It's tied to the string. Maybe this is like, what is that, tether ball. You know, it's like on a pole or something. I don't know. And it's swinging around here. All right. So we know the no, we know the acceleration, centripetal acceleration, is 4 meters per second squared. We know the mass of the ball. Mass is 0.25 kilograms. What is this force that this string is applying to the ball to keep it from going flying off? Because if you hit a ball, it's going to go straight, but it's curving around here by someone, you know, hitting it or something. So what's this force of the string that's keeping it going in this circular motion? That's what we're looking for, the centripetal force. So if you read Chapter 5, you probably know the equation. Or you might remember from Chapter 4 that for a force, it's equal to the mass times the acceleration. Okay, so we know the acceleration, we know the mass, so all we got to do is plug into this equation. So C equals the mass of the ball times acceleration of 4. I'll let you plug that in. Remember the units. We have meter per second squared times kilogram. The unit should be newtons. So whatever we get from doing this math, the unit should be newtons. All right, we'll stop there.